sometimes you'll have a quadratic. I'm going to go over example 4 from our textbook, and I'm going to do this twice. So sometimes you'll have a quadratic and it's in general form, of the form ax squared plus bx plus c. C is always going to be your constant term. A is always going to be your leading coefficient, and that's going to tell you if your parabola opens up or down, and if there's a vertical dilation on it. So in this case, my a value is -3. That's the number before the x squared, or before the quadratic term. So that tells me that it opens down, and it also tells me that I have a vertical dilation of 3. Okay, so if I want to graph from general form, this c value is actually always going to be your y-intercept. Okay, so if I'm at a y-intercept, that means I'm on the y-axis, so the point 0, 2 is my y-intercept. And then what I also need is my vertex. So if you check your chart in the first column, if you're going to find your vertex, what you need to do is find the x value of your vertex. Your x value of your vertex is always going to be opposite of b over 2 times a. So if we're in general form, the number before the quadratic is my a, the number before the x is my b, and then the number at the end is my c. So here, I'm only going to use the numbers, not the x. My b value is 6, so I would do -6 over 2 times a. In this case, a is -3. So this comes out to be -6 over -6, which is just +1. So my vertex is going to be located at 1, and I need to find my y value. In order to find my y value, I evaluate by plugging in the x value I just found. So on your chart, it says f of -b over 2a, but you're going to find out what -b over 2a equals before you plug it in. So -b over 2a is 1, so I'm going to evaluate f of x by plugging in 1. So this would be -3 times 1 squared plus 6 times 1 plus 2. So this would be -3 plus 6 plus 2, which is 3 plus 2 is 5. So that means my vertex is located at 1, my x value, 5. Okay, and I also know my y-intercept is located at 0, 2. So to graph from general form, I'm going to put the points that I know on here. So my vertex is at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 5, so 1, 2, 3, 4, 5. And I know that it opens down. I know my y-intercept is at 0, 2. I can put that on the graph. And then I'm going to use my parent table to help me come up with my other values. So -2, -1, 0, 1, 2, 4, 1, 0, 1, 4, 0, 0 is where my vertex is located. In this case, it opens down, so I have a reflection over the x-axis, so that's negative. And I have a vertical dilation of 3, so I'm going to multiply my y values by 3. So this becomes -12, -3, -3, -12. So from my vertex, I'm going to go left 1, down 3. Oh, I already found that point. That's also my vertex, also my y-intercept. And then I'm also going to use my driving direction. So I'm going to go to the right 1 and down 3. So I go right 1 and down 3. And then I continue on. I go left 2, down 12. So let's see, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, somewhere down here. And then I also go to, oops, I was left 2, down 12, and this is right 2, down 12, so I go right 2, down 12. And then I'm going to draw in a sketch. So if you have an a value that's negative, you open down. You can multiply your parent table by the 3 in the front. I know my vertex by using -b over 2a, and I plug that back in, and then my y-intercept. So here is a sketch of my quadratic from general form.